Okay, you should have hyperbola notes out and be looking at a graph of a hyperbola. If you remember on conic sections, when I started off with conic sections earlier this week and showed you that picture, the hyperbola was when you had the two cones stacked, right, and the plane goes vertical. And so they kind of look like parabolas, like two opposite parabolas, but yet when we draw them like this, they're a little wider than parabolas generally, okay? Also, I don't know if you guys, I know it's been a while, lesson 1-3, those 12 graphs, the reciprocal graph was hyperbolas. The reciprocal graph had the graphs in quadrants 1 and 3. That was the reciprocal graph. Those are hyperbolas. Now, the hyperbolas we're working with, as you look, are either horizontally out on the x-axis or vertically on the y-axis. Okay? So, officially by definition, hyperbola is a set of all points in a plane whose distances from two fixed points have a constant difference. So last time it was they have a constant sum. Now they have a constant difference. And thus, instead of my curves going in, they're going out. The fixed points are still called the foci, plural for focus. The line through the foci is still called the focal axis, so going from one foci to the other. The point halfway through the focal axis is still the center. The points where the hyperbola intersects its focal axis are the vertices. Okay, plural for vertex, of course. So as you look at the drawing here, you've got a drawing with all of your labelings. Notice this is what I'll call a horizontal hyperbola. Okay. Notice you've got your center. Your center is that point just in the middle. It's not actually on the hyperbola, it's just in the middle. Notice what happens here. The vertices are actually on the hyperbolas. Okay? So those are the points that are closest to the center on the hyperbolas. And then the foci, they are inside the hyperbola, so to speak, but that makes them past the vertices. It's kind of like, do you remember on the parabolas, how the focus was inside the parabola? It's the same thing happening here. Now, what this changes, if you remember the ellipse, on the ellipse, my vertices were farther out, and then the foci were inside, closer to the center. This reverses it. I've got the center, I've got the vertices, and then I've got the foci that are farther out on that axis. Okay? Other big difference on the ellipse, we had major and minor axis. Well, now the major axis is the transverse axis, and the minor axis is the conjugate axis. So the chord lane on the focal axis connecting the vertices, so what goes through here is your transverse axis, from vertex to vertex. The perpendicular line through the transverse axis is the conjugate axis. So it's not drawn in this picture, but we'll be drawing it as we do our pictures. But it goes vertically through the center. That is your transverse axis. Now, we will be drawing those because as we learn how to draw these hyperbolas, it's going to be very important that we draw a set of asymptotes. Okay? So, okay, I think I got all the vocab there. Like ellipses, we're going to have two sets of charts. A set of charts with hyperbola centered at 0, 0. That'll be kind of our breaking in here. And then we'll get to some hyperbolas that are not centered at 0, 0. Okay, guys, difference with the equation this time. What's different from the ellipses? Okay, there's only one difference on standard equation. In the middle, it is a subtraction sign instead of an addition sign. Now, you'll notice there's a left column and a right column, yes, or column 1 and column 2, however you want to say it. Maybe I should say a horizontal column and a vertical column. Notice, though, in that first column, it's x squared over a squared, okay? In this next column, it's y squared over a squared. So part of my difference here is that a squared is always going to be on the first fraction. It'll be the x or y that flips. And because there's that subtraction sign, we can't just flip-flop them around as much as we'd like. Now, this also means, I'm going to say it now, say it lots of other times, A is not necessarily the bigger number here. That is specific to ellipses. Okay? So just kind of knowing that. We've got some foci and vertice information, which you'll notice is the same as in the ellipse. Transverse and conjugate axis, just like major and minor axis. Pythagorean relationship. What do you notice about the Pythagorean relationship? Yeah, this one has a plus sign. When ellipses, it had a minus sign. Okay? And then we have something else added on here, which are the asymptotes. You see the asymptotes drawn in there as the x, right? The asymptotes are what help me to figure out how wide to draw my hyperbolas. Okay? So we will be drawing in the asymptotes to help us draw the hyperbolas. So when I ask you on something to draw a hyperbola, like if you're asked to do that on the test, I will be looking for appropriate placed asymptotes. And I'm going to show you how I teach that at least. Okay? So, some of these skills carry directly over from ellipses. Some of them are slightly different. Example 1. Find the vertices and the foci of the hyperbola. You guys got a starting point for me? Yeah, we can't really do a whole lot because in order to find vertices and foci, we have to know A and C, but right now it's not in standard form. So how are we going to get it into standard form? Yeah, just like in an ellipse, you're trying to get it to equal 1, and so we need to divide by 36. So this part should be old news to you, right? So what do you know about 4x squared over 36? X squared over 9 minus 9 over 36 makes this y squared over 4 equals 1. If I rewrite this in terms of, instead of saying 9 and 4, it's saying a squared and b squared, how do I rewrite 9? It's x squared over 3 squared minus y squared over 2 squared equals 1. Now, left column, right column. Left column because x is first. Okay, so this time it is more not about where your larger denominator is, it's which one has the positive, right? So this is a left column, if you will, and maybe I probably need to transition and say horizontal and vertical, but too late now. What do we know? What's A and B? Okay, A is 3. B is not B. B is 2. Okay. So they asked me to find vertices and foci. So it's a left column problem. What's it say up there about vertices? Formula says plus or minus a, comma 0. So what are my vertices? Plus or minus 3, comma 0. Okay? Foci. Okay, my formula says plus or minus c, comma 0. Okay, just like the ellipses, as long as you know 2 out of the 3, you can find the third of your ABCs. So, now, what's your Pythagorean relationship we're using this time? C squared equals A squared plus B squared. Yes, it is also Pythagorean theorem. I'm not going to call it that because I don't want to, muddy the water. But if you're trying to remember it, It is, for the hyperbola, it is specifically the Pythagorean theorem. Whereas for the ellipse, you change the sign. So. Okay. You guys probably have this done. C squared is what? 9 plus 4. So 13. So C is square root of 13. And so what are my foci? Plus or minus square root of 13, comma 0. That shouldn't have seemed too bad. Considering we just did ellipses, right? Huh? Yeah, exactly. Okay, example 2. Find an equation of the hyperbola with foci 0, -3, and 0, 3, whose conjugate axis has length 4. Sketch the hyperbola and its asymptotes. Okay, I'll save the sketch for last. Okay, because that's a whole new teaching. I got to teach the hyperbola here. But the rest of this works a lot like ellipses. So what kind of things are you going to share with me? Okay. I hear C equals 3. Why does C equal 3? Because we're told the foci, yes? And if it helps, you can think of this as 0 plus or minus 3, which falls into the category 0 plus or minus C, which means, which column am I in? Because that C is in the Y position, this is a right column, or in other words, it's going to be on a vertical axis. Okay. What else you guys going to tell me? What's 2? B is 2. Okay. Conjugate axis. So this was foci. Over here we have conjugate axis has length 4. What's it say about conjugate axis up there? Yeah. So 2b equals 4, and thus b equals 2. Take a guess what we still need to find. Hey, yeah, we're going to have A and B to write an equation. How do we find A? Okay. Pythagorean relationship, yes? So officially it's C squared equals A squared plus B squared. Manipulate that how you need, right? So A is what? Square root of 5. Okay. Now, based on the fact we are going to have to graph this, right? It is helpful for the equation, leave it at square root of 5. For when we come to the point we need to graph this, it is helpful to know what the square root of 5 is. I have written down 2.23. You said 2.24. It must be something. It could be I didn't round. You put 2.2. Hey, that makes us both right.
2.236.
Okay, so you rounded, I didn't round. Okay, got it. Which, honestly, at that point, it's just going to be putting it a little bit past 2. There's not going to be a whole lot of specificness. So, do we know enough to write my equation? Yeah. So, I'm leaving room for my graph in the middle, so I'm going to come over here at the left side and do my equation. Leave room for a graph somewhere. Okay? So, it was the right equation. So, y squared over a squared minus x squared over b squared equals 1. So, what do we have here? Okay. Y squared over 5 minus x squared over 4 equals 1. Okay. Okay, there is my X and Y axis. Okay. I guess I'm going to okay. We are going to start with our A, B, and C values. Okay. A, B, and C values work very similar on hyperbola as they did on an ellipse. Okay. Remember, what did those A, B, and C values tell you? Or A and B tell you how far to count out, right? Either count up and down or left to right, depending on the situation. Now, in this case, A is that square root of 5, or 2.23. And if you look up in the picture, A represents the what? That is going to be my vertices. A is also, if you look over your equation, A is under what variable? A is under the Y. So that means in the Y direction, we're going to count 2.23. So I'm going to count up 2.23, 2.2, whatever, and I'm going to count down 2.2. I'm going to label that as A. Okay? Now, while we're at that, those represent, and I should have put on there, vertices. So my A values are my vertices. While we're here, let's go ahead and count C. A are the vertices. What are C's? The foci. And so your vertices and foci should be next to each other, right? What was my C value? 3. So that means on that same axis, I was counting up and down 3. And those are my foci. And remember, that's what we want it to be because our foci are inside the hyperbola curves. Okay? The other thing I need you to do is I need you to count your B's. Now, A's are on that main axis, which is the, what's the word? Transverse axis. I lost it for a moment. Okay. B's are more on the minor axis, which now the minor axis is the conjugate axis. My B value was 2. So that means I'm going to count left and right 2. Now, the idea here, I guess maybe I shouldn't have actually put dots there, but I did, so it's fine. The idea is your A's and your B's. We're going to use our A's and B's to draw a box that can then help us place our asymptotes through the corners of them. Okay? I'll be honest, I rarely actually find the asymptote equation because I go with drawing a box, and I think it's easier that way. So what I'm going to do is I'm going to draw a box through my A's and B's. So vertical lines, just dotted lines, through my B's and through my A's. So I'm going through the -2 and +2 on the x-axis, 2.2 and -2.2 on the y-axis. I have a box, yes? Not necessarily a square, but it's a box. Your asymptotes go through the corners of those. So when I draw in my asymptotes, they're going through the diagonal corners. They also should be going through your center, which in this case, my center is 0, 0. Yes, I want to see your asymptotes. Yes, I should see that box drawn in lightly. Now, the asymptotes, all they're doing is they are helping shape my hyperbola. Where do my hyperbolas go through? They go through your vertices, which are your A values. So you touch that point, and then the idea is that those asymptotes help you shape, okay, is this hyperbola really skinny? Is it really wide? What is it doing? And you have drawn your first hyperbola. As I said, yes, I will be looking to see that light box in there because that's what helps you draw your asymptotes. Yes, I definitely need asymptotes and the rest hyperbola. Notice my foci are inside those curves, right? Questions I should answer on that? Similar but yet different from ellipses, right? A lot of similarities. Now the drawing's totally, well, let's look at the A's and B's, so I can't say totally different. Okay, on the back side, what's different? Instead of being centered at 0, 0, they're at HK. Okay, so notice it's just like ellipses, right? H is with the X, K is with the Y. Same idea here. You'll notice your foci, vertice formulas, they look similar to the ellipses that we had. Transverse conjugate axis are the same. Pythagorean relationship is the same. Formula for the asymptote changes now because there's H and K involved. Okay, but again, you don't have to write out the asymptote formula that often. I don't know. We do it over on the next page, but you don't have to write out that often. Okay, so you have the charts there. I don't know that I need to really say a whole lot more about that. So we also talk about eccentricity again. Eccentricity of a hyperbola is E equals C over A. So that formula is still the same, and it just talks about, remember on the ellipse it was how elongated it is? Same type thing, which in a hyperbola turns into, you know, how wide or narrow it is. Okay? Okay, start looking at example 3. Find the standard form of the equation for the hyperbola whose transverse axis has endpoints -2, -1, and 8, -1, whose conjugate axis has length 8. Now, I'll be honest, I don't know if we have to, but we're probably gonna use this in practice draw another one too. So, okay. What information have you spotted that's helpful here? Endpoints. Okay, so transverse axis endpoints of -2, 1, -1, and 8, -1. What are those? Vertices, right? Vertices are always at the end of that major or transverse axis. So those right there are vertices. Huh? How are you telling it's left column? Okay. So Mallory's saying it's left column because my Y value stays the same. Okay. So it's -2, -1, and 8, -1. So that means K has to be the same. And so that does make it a left column problem. You can also graph it, right? If I graph -2, -1, and 8, -1. Those points form a horizontal line, yes? A horizontal line makes it a left column problem. So if this is left, I'm going to write down my formula. X minus h squared over a squared minus y minus k squared over b squared equals 1. Can you tell me anything about the length of the transverse axis? Yeah, talk about the transverse. How long is the transverse axis? Can you guys visualize that? If it goes from -2, -1 to 8, -1. How far apart are -2 and 8? 10. So how long is the transverse axis? It is 10. So what's that helping me figure out? Where am I going with this? Yeah. Transverse axis is 2a. We just figured out it's 10 long, so 2a equals 10, and thus a equals 5. Okay. Oh, okay, I'll get to that in a moment. Okay, can I talk conjugate axis for a moment? What do you guys see on the conjugate axis? Yeah, conjugate axis has length 8. And if it has length 8, what's that tell me? 2b equals 8, and thus b is 4. Okay. The other thing we haven't found, we need to know h and k. Technically, we should know c, but honestly, it doesn't say we have to graph this. We can get away without finding c on this one. H and k. Can you do it without graphing it? What's in the middle of -2, -1, and 8, -1? It's got to be something -1, right? What's halfway in between -2 and 8? Count 5 in and you're at 3. And that is my HK. So can you write that equation? Let's do it. I'll draw my graph at the end, I guess. What's my equation then? X minus 3 squared over 25 minus, you don't put that minus sign in, you're going to miss it. Okay. Y plus 1 quantity squared over 16 equals 1. I know it doesn't say to graph it, but I just want to practice real quick with you guys because I, need to make sure that we're comfortable with these graphs. And trust me, next week when we are reviewing for chapter tests, you guys are going to be questioning, okay, wait, how do we graph these? Okay, so we had points at 8, -1, and -2, -1, and those were my vertices. Yes? If we haven't already done the rest, you've got your vertices, yes? Can you find your center if you haven't already found it? You can find your center by just counting in, right? There's a distance of 10, so count in 5 each way. So there's that center we already had. Okay. How do I actually graph this? Officially, A was what? 5. And those are already counted out. Those are my A values right there, yes? They're already counted out 5. What else do I need to do? B. B is 4. So what do I need to do with that? Yeah, count up and down 4. So that means I'm going to go up 4 here. And down 4 there. What do I do with those A's and B's? Or what am I asking you to do? Draw a box with your A's and B's. Can you see my A's and B's? I do them in pencil, but and what does drawing that box help me do? So you can draw your asymptotes through there, right? Asymptotes should go through the diagonal corners and through your center point. Now I can tell that my hand-drawn graph is a little lopsided here. But that's just me not spacing it out, everything out evenly. And where do I draw my hyperbolas? The left and right, the vertices. Through the vertice and running along the asymptotes. Are we feeling okay about drawing the hyperbolas? The key will be, do you remember come Monday how to draw them? That might be the trick. Okay. Let's try example 4. Find the center, vertices, and foci of the hyperbola. So you don't even have to really identify. I was going to ask which column is this, but Mallory's all about telling me the center. So I agree. Can we go straight for the center? Center's going H and K. So what's my center? X has to be -2 and K has to be 5. And again, that's because HK. Now, I would like to identify before we proceed any farther, though. Left column, right column. Column 1, column 2. Horizontal, vertical. However you want to refer to it. Which one is this? It's column 1, left column. Why is that? Because X comes first. What do you notice about this one? The bigger number's over there, isn't it? But that's just the way it works. Okay? This is a left column problem because X comes first. So this is of the form, if I write it in here, X minus H squared over A squared minus Y minus K squared over B squared equals 1. We already talked about H and K, yes? I mean, I can write them down. No. We already talked about the fact that h is -2 and k is 5. Can you give me a and b? Okay, a is the square root of 9, so a is 3. B is the square root of 49, so b is 7. Am I going to need to know c? What else do I still have to find? Vertices and foci. Foci always require the use of c. So let's go ahead and find c. How do I find c? C squared equals a squared plus b squared. So 9 plus 49, which is 58. So square root of 58. Okay. I've got to find vertices and foci. What about vertices? Do I have a formula for vertices? H plus or minus A, comma K. Because we know we identified X as first, it's left column. Since X is first, that means everything's added or subtracted to the X coordinate. Okay, have you done the math? -2 plus or minus 3, comma 5. What are you going to give me? Okay. 1, 5 and -5, 5. And the only thing that changes up on C? No. The only thing that changes up on foci, A becomes C. So H plus or minus C, comma K. So what do we get? -2 plus or minus square root of 58, comma 5. If we're graphing it, I'd want to go and find decimals because I would want to know where to graph those. Since I'm not graphing them, I'm going to leave them as is. Okay. As you flip over to the next page, you'll see what we have left is example 5. Notice this example 5 is going to be like the one we did in the ellipses, right? There is no possible way I'm getting through that in the next 3 to 4 minutes. It's not happening. Reality. Okay, which I kind of figured this is about where I'd end up. So, what I will plan to do is Monday I will plan to go through one of these problems. We need to talk about asymptotes, and we need to practice on the last homework. 46 and 48 are the ones you guys had problem solving. We need to practice that solving because we're going to use that same technique. Okay, so I will do those on Monday. That means you should have some work time on Monday, and homework will be due Tuesday. Okay, that puts us. The only thing we have after hyperbolas that we do in this chapter is 8.4. And 8.4 is kind of almost a summary section. We talk about how to tell what type of equation is what and how to graph them with the calculator. And then we'll be ready for a test. Test could possibly be as soon as next Friday. That is the soonest it would be. And I can't answer if it's going to be next Friday until I'm just going to see how next week goes. I'd like to get in next Friday, but I might be pushing it. So, if not, it'll be the next week then. Yes.